Okay, hello. So we're now on our new topic for the midterms. So we will be solving this time system of linear equations. So when we say system of linear equation, so that is a group of linear equations with various unknown factors. So usually if we can recall in algebra, so the number of unknowns corresponds to the number of equations needed. Okay, if there are two unknowns on a given problem, so we need two equations to solve those two unknowns. So if there are three unknowns, so we need three equations for us to solve the system of linear equation. And there are different ways on how to solve or on how to find the solution of a system of linear equations. So in algebra, so if you can still recall, so to solve such equations, so we do elimination method or by substitution method. So there are other approach on how to do it. So we have using the augmented matrix and using the principle of transforming the given matrix or the augmented matrix into the row echelon form. So that is what we are referring as the Gaussian elimination. So in mathematics, so the Gaussian elimination method is known as the row reduction algorithm for solving linear equations or systems of linear equations. The row reduction algorithm or the row echelon form that is transforming the given matrix into an upper triangular matrix. So that is the diagonal comprises of all ones and or non-zeros, and then the lower triangle of the matrix are all zeros. And there are different ways on how to transform a given or the augmented matrix into a triangular matrix. So that is one by swapping two rows, and this can be expressed using the notation such as these. So this means that we're going to swap row 2 so from row 3. So we're just going to interchange the row 2 and row 3. So the second one is by multiplying a row by a non-zero number. So for example, given the row 1, okay, so will be transformed into KR2. So that means we can multiply the entire row by a constant. So that is what we are doing in a given equation. So if we multiply the left-hand side of the equation by a certain constant, so that is the same thing that we need to do at the right-hand side of the equation. So this is the same as true for the augmented matrix for the systems of linear equation. And the other one, so we can add multiple of one row to another row. So for example, the R2, so will be R2 plus 3R1. So this, the third approach is the one that we will be using. So to transform the matrix into a triangular form. In Gaussian elimination, so these are the steps that we're going to follow. So for us to solve a system of linear equation. So one would be, write an augmented matrix for the system of linear equations. So that means we are going to get the coefficient of all the equations or the different sets of equations, and then we're going to transform it into a matrix format. And then once we are done, so that is the time that we're going to transform it into a row echelon form. So the row echelon form, so that is transforming the matrix into a triangular matrix. And then afterwards, so we're going to solve the system of equation using back substitution. So we need to find the solution of the equation through back substitution. So after transforming the equation into row echelon form. Another method in solving systems of linear equations without the use of the back substitution, that is by using the Gauss-Jordan elimination. So Gauss-Jordan elimination, so transform the matrix this time into a diagonal matrix. So that means all the diagonal of the given matrix will all be 1. or that is what we are referring as the reduced row echelon form. And then once we are done, so that's the time that we're going to solve the system of equations. So we're just going to solve the system of equations. So let's have this example. So solve the given system of linear equations. So using Gaussian elimination, that's the first one. And then the second is using Gauss-Jordan elimination. So for the first one that is through Gaussian elimination. So we are given three unknowns here, so which are x, y, and z. So there are three equations as well. So we just need to find the solution of the given equation. So using Gaussian elimination and Gauss-Jordan elimination. So for our first step, so in solving this equation, that is to transform the system of equations into an augmented matrix. So to form the augmented matrix, so we are just going to get the coefficient. So we're just going to write the coefficient. So that is, so for this one we have 2. So for the coefficient, and then we have -1, then +3, and then we have 9. So for the constant. So for the second we have 1. Then we have, this is 1 as well. So we have z is 1 as well. And then 6 for the constant part. And then we have 1. So we have to follow the sign as well. So this is -1. And we have +1 and +2. So we can actually verify so whether or what will be the solution of these. So let me so let's try to solve this one, or let's try to find okay, split view. I'm going to open this one. So let's try to find so using our calculator, so we can solve this using our calculator. So we can find for the values of x, y, and z. So what would be the value of x, what would be the value of y, and then what would be the value of z. So I'm going to use this one. So we have x, okay, so system of equations. So we have three unknowns. So I'm just going to write it down. So that would be 2 and -1, +3, and then a 9. So we have 1, 1, 1, and 6, and then we have 1, and -1, 1, and a 2. 2, -1, 3, 9, 1, 1, 1, 6, 1, -1, 1, 2. So it can be seen that x is equals to 1, then y is 2, and last 3, z is 3. So that is using calculator. Okay? So you can also use elimination method or substitution method for checking. However, so it's very specific that our method of solution should be Gaussian elimination. So our objective here, okay, so our objective is to transform the equation into this form. So that means I should have a diagonal, so which is 1, 1, and 1. Okay, so and then I'll have, it should be 0 here, a 0 there, and a 0 here. And then regardless, okay, so whatever would be the values, okay, so for the rows and columns. So by the way, so for the first row, so that corresponds for the first equation, second row, so this is the first row, second row, and then the third row. So we have the first column, second column, the third column, and the fourth column. So our designation for the first row, so that is R1, second row is R2, and the third row is R3. So usually, in Gaussian elimination and even in Gauss-Jordan elimination, So we write our formula, okay, so based on the row, okay? And our objective is this one. So to make the diagonal, everything should be equal to 1. And then the lower part should all be zeros. And then regardless, whatever would be the values for these x's. Okay? So now is how are we going to do that? So the first objective that we want is to make, okay, so to make the first row and first column to be equal to 1. So remember, there are three ways on how to do it. So it's either we interchange row, so we multiply the entire row by a constant, or we multiply the entire row by a constant and then add another row. That is on how we are going to transform it. But in this case, as you can see, our first approach here is we start with the first column. So we start with the first column. Our main first objective is to transform the first row, first column into 1. Okay? So that's our first objective. So this, once we transform this, the first column and the first row to 1, okay, so the next move is to change all the rows below that column, okay, so rows below that column to 0. Okay, so that is for the Gaussian elimination. So we transform first the diagonal into 1, or particularly we start with the first row. Okay, so when we start with the first row, we transform, okay, the element. By the way, that element is what we are referring. So this is what we are referring as the pivot element. So our pivot element should be 1. So we need to transform that 1. So when we say pivot element, so this is our reference, okay, and then this entire row then, where the pivot element belongs is what we are referring as the pivot. That is the pivot row. Okay? So the pivot row is where the pivot element belongs, and then the pivot element is our reference element that we're going to transform into 1. Okay, so how do we do that? So remember that we can interchange. Okay, so we can interchange row. So I can make this one as like this. So I'm going to transform row 1 so to row 2. So transforming row 1 to row 2, so that would transform it into, so this is row 2, okay, so this is row 2, so that would make it 1, 1, 1, 6. And then, so our row 2 becomes the row 1. So this is 2, negative 1, a 3, and a 9. And then a 1, a negative 1, a 1, and a 2. So in this case, our pivot element, so from 2, it is now 1. Okay? So once we have that, we're going to transform. Okay, so we're going to transform the second row and the third row below the pivot element to be 0. So how do we do that? So we have this formula. Okay, so our formula, so will always be, it starts with the pivot element. So in this case, our pivot element is pivot row, not pivot element. It's a pivot row. So our pivot row is the first row. Okay? So in this case, our pivot row is the row that contains the pivot element. So which is row number 1. So we just write there, so row 1, and then for this one, so that is row 1 as well. And then we multiply the coefficient, okay, or the element for below the pivot element. In this case, that would be 2, and then that would be 1. Okay, so for R1, or we're not going to write it anymore. And then, so for to make this one 0, then we just write, so this should be row 2. So since this one is row 2, and then this is row 3, that is row 1. So, and then I'm just going to write row 3 here, and then subtract it, or minus. So that would be our formula this time. So this is to transform, okay, so the elements below the pivot element to be 0. Okay, so to be 0. So that means this is row number 2, or row number 2, so we multiply it with, or we subtract 2 times R1. So how do we do it? So for example, so in this case, so this would become a 1, a 1, a 1, and a 6. So since there's no formula there, so it's already 1. So I'm already okay with that. So now is I'm going to use this formula. So when I say R2, so that means this is the row 2, which is 2. So which is 2. And then minus 2. Then our R1 is this. Okay, so in substituting, so we always go with the same column. Okay, so if R2, okay, so R2 here, so which is 2, and then minus 2, our R1 there, so would be 1. So multiply it with 1. So that makes it, so 2 minus 2 to be 0. And the same as true with the third row. Okay, actually before even doing that, so I can make this one, so 2 minus 2 times 1, that will be 0. So this is already 0. So next, for the second column, so the same thing. Okay, so we just change this one. So I'll have row 2, so which is, this is row 2, negative 1. And then minus 2, our row 1 this time, it's positive 1. So that makes it, so negative 1 minus 2, that is negative 3. Negative 1 minus 2, that is negative 3. So I'll write here negative 3. That is for the second column. And we proceed with the third column. So for the third column, as you can see here, so the negative 2 remains because what we are changing here is R2 and R1. So this time our R2 is positive 3, then minus 2, our R1 is positive 1. So multiply it with 1. So 3 minus 2, that would be equal to 1. And we have 1 there. And lastly, so we have R2, so which is 9, then minus 2 times R1, so which is 6. So 9 minus 12, that is negative 3. So I'll have negative 3 there as well. So that is for the second row. So for the third row, so the same as true. So I'll just have minus 1 for R3 minus R1. So our R3, so this is our R3, which is 1, and then our R1 is 1. So 1 minus 1 is 0. So that's, I'll just have 0 there. And then for the next one, so I'll have a negative 1 minus, or a negative 1, then minus 1, so that is equal to negative 2. So that will be negative 2. And next, so we could have this one, so which is positive 1, positive 1, then minus 1, which is 0. So 1 minus 1 is 0. And then finally, so I'll just have 2 minus 6, 2 minus 6, that is negative 4, which is negative 4. And what should we do? Okay, so once we are done, so this time, so we are done with our first column. Okay, so as you can see here, this is already okay. So that is 1, 0, 0. So our next objective is this one. So it should be the second row, this time becomes our pivot row. Okay, and then so we are going to transform, this should be equal to 1, and then anything below should be 0. So to do that, if we don't want to interchange the rows anymore, so we can use the second transformation, that is by multiplying an inverse. Okay, so multiplying an inverse of the row. So in this case, so what I can do, so I want this one, okay, so this to be equal to 1. So to do that, so what I will do is I'm going to multiply a negative, so I'm going to multiply a negative 1/3, okay, so to the second row. So doing that, I'm just going to rewrite it. So 1, 1, 1, 6, and then for the second row, so that is again, so 0 or negative 1/3, so times 0, so this is 0. So this is 0, and then I'm going to change this. So for the second column, that is negative 3. So negative 1/3 times negative 3, so that will be positive 1. So this time it's already 1. And then for the third column, that is negative 1/3, so times 1, so that makes it negative 1/3. So I have negative 1/3. Then the last one, so we have negative 1/3. Okay, so negative 1/3 times 3, so that is negative 1. So we have negative 1 there. So by the way, we can transform this into a matrix, so we can create a bracket there, okay? And then since these are constant, so I can write okay. And then afterwards, I'm just going to rewrite, so 0, negative 2, 0, and negative 4. So that is how we usually do it. Okay, so we transform the pivot element into 1. And then afterwards, so change all the elements below the pivot element to 0. So for the second pivot row, so which is the second row, so I was able to transform it into 1 already. My next objective is to transform. Okay, so to transform the element below, so to be equal to 0. So to do that, so similar with our formula before, so we'll start with the pivot row. So in this case, our pivot row is this, so which is row 2. Okay, so row 2 is our pivot row, and then our reference row would be row 3. And then what I want is to write, okay, so the coefficient. So this is negative 2, so minus negative 2, so that will be positive 2. So that will make it positive 2. So R3 plus 2R2. So to do that, so to apply that, so I'm just going to copy, so 1, 1, 1, and 6. And then I'll still have 0, a 1, a negative 1/3, and a negative 1. And then, so we write down, so R, so it's still, this is always plus 2, so R3 is 0, and then we start with here, so 2R2, so R2 is 0 as well, so 0 plus 0 is 0, so thus this is still 0. And next, so we have a negative 2, and then a positive 1. So negative 2 plus 2, so that is 0. So that's transforming it to 0. And lastly, oh sorry, second to the last, so we have a 0, and then we have a negative 1/3. So a 0, so for R3, and 2 times negative 1/3, so we have negative 2/3. So this would be negative 2/3. And lastly, so we have a negative 4, and then 2 times a negative 1. So negative 4 minus 2, it's negative 6. So which is negative 6. And finally, so I want to make the third column, okay? So the pivot element this time, so would be this one. So I need to transform this into 1. So to do that, I'm just going to multiply it with the inverse of that. So which is negative 2/3, so that is 3/2. And then multiply it with R3, and then it should be negative. Positive. Negative 18 divided 2. That is 9. There's something wrong. It's always a negative 1/3. And we multiply it with the first one. However, so I'm just going to rewrite. So the first row, so 1, 1, 1, and a 6. And then I'll have a negative 1/3, so times 0, so that is equals to 0. So we have a 0 here. And then we have a negative 1/3, so times R2, which is negative 3, so that makes it positive 1. And then for the third column, so which is 1, so negative 1/3, so times 1, that is negative 1/3. And then, so we have the last column, so which is negative 1/3, so times negative 3, so that would be positive 1. Then we write the equation, or the third row, so which is 0, negative 2, a 0, and a negative 4. And afterwards, so we need to transform all the elements below the pivot element to be 0. In this case, again, so this one becomes our pivot row. Okay, so our pivot element is already 1. So what I need to do now is to change this negative 2, okay, so into 0. So to do that, so we start with the pivot row. So our pivot row is row 2. So we write row 2. And then our reference row, so which is row 3. And then since this is negative 2, so that is minus negative 2, so that will become plus 2R2. And thus, I'm just going to write the first two rows. That is 1, 1, 1, and a 6. Then for the second row, it's 0, 1, a negative 1/3, and a 1. So we follow the formula. So R3, so our R3 is 0, and then plus 2. So our R2 is 0 as well. So that's 0 plus 0, that would be 0. And next, so we have for the third row, so which is negative 2, and then R2 is positive 1, so negative 2 plus 2, that is 0. So that's transforming it to be 0. And then second to the last, so we have a 0, and then for our R2, so 2R2, which is negative 1/3. So negative 1/3, that is negative 2/3. So negative 2/3. And then finally, so we have a negative 4, so for R3, and then a positive 1. Okay, so for R2, so negative 4 plus 2, that is negative 2. So that makes it a negative 2. And lastly, so what I want is for my pivot row this time, so would be the third row. And then my objective is for this pivot element to become positive. So to do that, so I'm just going to multiply it with negative, and then the inverse of 2/3, so which is 3/2, and then R3. So that's making it to be equal to, so 1, 1, 1, and a 6, a 0, 1, a negative 1/3, and a 1. And then, so using this formula, there's negative 3/2 times R3. So our R3 first is 0, so therefore that is 0. And then, if it is 0, it's still 0. So what we have this time, it's negative 2/3. So negative 2/3, so that would become, so 3 and 3 will cancel out, 2 and 2 will cancel out. So negative and negative, so that would be positive 1. So this time, so it's now positive 1. Then lastly, so we have a negative 2/3. So multiply it with negative 2. So that makes it, so 20 will be cancelled out, so that is positive 3. And this is already the row echelon form. Okay, so the matrix is in a triangular matrix, so that means the diagonals contains all ones, and then the upper portion of the matrix are all non-zeros, and then the lower the elements below the diagonal are all zeros. So this is what we are referring as the row echelon form. And from here, so we do back substitution. So again, so how do we do the back substitution? So the first step is the augmented matrix. The second step is to transform it. Okay, so this is our step 2. So we were able to transform it into the row echelon form. So that is the REF, or the row echelon form. And then our step 3 is use the back substitution. For the back substitution, we we transform it back to equations. Okay, so we transform it back to the linear equation. So in this case, so how do we do that? So to do that, so we have here, so it says that again, so this is for the x, this is y, this is z, and then this is our constant. So as you can see here, the element for x is 0, so that's why we don't write it anymore. For y, it's 0, and then for z, okay, so using the third column or third row, so that makes it z, okay, so which is equal to 3. And that is the same as this one. Okay, so based on our calculator, that z is equals to 3. And then, so for the second one, so we're going to use the second row. So for the second row, so we have a 0x and a positive y. So y, and then a negative 1/3. So negative 1 over 3z is equals to positive 1. So using the second row, so a positive 1, okay, so which is y, a negative 1/3, negative 1/3 z, and then the constant part, so which is 1. And from here, so we substitute, so y minus 1/3, so our z is positive 3, so which is equals to 1. Then y, negative 1/3 times positive 3 is negative 1 is equals to 1. So y will be equal to, so transpose that 1, so y is equals to 2. So z is 3, y is 2. Then lastly, so we have the 1, 1, 1. So we use the first row. So 1, we have x, a y, and a z is equals to 6. But then, so we have y, which is positive 2, and then z, so which is positive 3 is equals to 6. So x plus 5 is equals to 6, so x is equals to 6 minus 5, so x is equals to 1. And thus solving the system of linear equation. So this is what we are referring as the Gaussian elimination. Okay, so this is the method for Gaussian elimination. So for the second one, so we're going to use the Gauss-Jordan. So for the Gauss-Jordan, so we're just going to continue. Okay, so we're just going to continue the matrix that we've used for the row echelon form. So this time, so we need to transform this one into a reduced row echelon form. Okay, so what's the reduced row echelon form? So the reduced row echelon form is like this. Okay, so the diagonal should all be equal to 1. And then, so this is the row echelon form. The reduced row echelon form, so including the upper portion, okay, of the diagonal are all zeros. And then regardless, whatever would be the value at the constant part. So in the Gauss-Jordan elimination, so if in row echelon form, so we start, so this is how we do it. We start with the first column, the second column, and then the third column. In reduced echelon form, so we start with the third column, and then we end up with the second column. Because the last column is already 1. Okay, the first column is already 1. Okay? So how do we do that? So we start again. So I'm just going to copy this. Okay. And then we're just going to clean it up. Is that correct? So 613. So 613. So we already have okay. So our pivot element are already all ones. Okay. So the only thing that we need to do is to transform. Okay. So the first thing is this one. Okay. So we start. Okay. So we start with this third column. Okay. So how do we do that? So again, so we start with the reference row. Right. So reference row minus the pivot row. So what is our reference row? So this is R1, this is R1, and then this is R2. What's our pivot row? Our pivot row is this one, so which contains the pivot element, so which is 1. So that is R3. This is R3. And then we just copy the coefficient. Okay, so that is minus R2 minus. So minus negative 1/3. So that is positive 1/3. Then minus 1, so that is just R1 minus R2. So we start with R1 minus R3. So R1, okay, I'm not going to write this anymore. Okay, so the R1 is 1, R3 is 0. Okay, so R1 is 1, R3 is 0. So 1 minus 0, that is still 1. And then, for the second column, so 1 minus 0 as well. So 1 minus 0, it's still 1. Then, for the third column, so we have 1 minus 1, so which is 0. And then next, so we have, so 6 minus 3, so which is 3. So 6 minus 3 is 3. And then for the second row, so we have 0 plus 1/3, 0. So 0 plus 0, that is 0. And then we have R2. So R2 is 1. So 1 plus 1/3 times 0, 0, so that's just 1. So that is just 1. And then I'll have, okay, so this time it's a negative 1/3. So for R2 plus 1/3, and then our R1 is 1. So negative 1/3 plus 1/3, that is 0. And then, so I'll have for the last one, so R2 is 1 plus 1/3, so R3 is 3. So 1 plus 1/3 times 3, so which is equal to 2. And then we rewrite the third column, or third row, 0, 0, 1, 3. So now that we are done with our third column, so the next is we move to the second column. So our pivot element is already 1. Okay, so this is our pivot row this time. It's already 1. So this is the only one that we need to transform into 0. So to do that, so we follow the formula. The reference row is R1. The pivot row is R2. And then the coefficient here is 1. So that would just be minus R1 minus R2. So to do that, so R1 minus R2, that is 1 minus 0 is 0. Or sorry, 1 minus 0 is 1. And then 1 minus 1 is 0. 1 minus 1 is 0. 0 minus 0 is 0. So 3 minus 2 is 1. Then we rewrite the second column, or second row. 0, 1, 0, 2, then 0, 0, 1, 3. And what can we see here? So in here, so right away, so this is x, this is y, this is z. So x is 1, y 0, 0. So that means the coefficient here is x is equals to 1. Then from here, the coefficient of x and z are 0, but y is equals to 2. Coefficient of x and y for the third column, or for the third row, are zeros, and then z is equals to 3. So that is for the Gauss-Jordan. So for Gauss-Jordan, so this is what we are referring as the reduced row echelon form. So the reduced row echelon form, so it's a diagonal matrix, and then so the resulting constants, so that would be the solution of the given system of equations. So that is x equals to 1 at 2 and at 3. And so we need to practice, okay, so to solve systems of linear equations. And that will be all. Good day.